Let's take a look at another functional equation. It is the problem 5 of the International Mathematical Olympiad 2002. It says find all functions f from real number to real number such that f of x plus f of z whole times the f of y plus f of t equals f of xy minus zt plus f of xt plus yz. Okay, so let's call it p of xyzt. Okay, so at the first step, let's try to replace all the four variables to be 0. So we can hopefully find f of 0. So let's see, p of 0, 0, 0, 0. We can see the first term will be 2f of 0 times 2f of 0. So on the left side, we have 4f of 0 quantity squared. And then equals, on the right side, it is f of 0 plus f of 0. So it is 2 times f of 0. So it means that 2 times f of 0 times 2f of 0 minus 1 equals 0. So which means that f of 0 equals 0 or 1/2. Okay, so that's great. And then it will separate into two cases. So for the first one, let's pick f of 0 to be 1/2 because it will be easier to go on. So let's try to pick p of x0, x0. Okay, so let's see. So we will have f of x plus z is also x, so f of x, and then times y and t are all 0, so f of 0 plus f of 0. And then on the right side, it is actually f of x times 0 minus x times 0, and then plus f of x times 0 plus 0 times x. Okay, so we can see that this is actually 0, so the whole term will be 1/2. This term is also the same. F of 0 is actually 1/2. So on the right side we have 1, and then here this is also f of 0 plus f of 0, which is 1/2 plus 1/2 to be 1. And then finally, we have 2 times f of x times 1 equals 1. So which means that f of x equals 1/2 for all x are real number. So this is the first solution. Okay, so for case number 2, we can try to have f of 0 equals 0. Okay, so after getting the value of f of 0, let's try to find f of 1 by picking p of 1, 1, 1, 0. Okay, so let's see what we'll get. So here we have f of 1, and then z is also 1, f of 1, and then times f of y is f of 1, and then plus f of 0. Okay, on the right side, it is actually f of 1 times 1 minus 1 times 0. Okay, and then plus f of xt, t is 0, so 1 times 0 plus 1 times 1. Okay, so this is actually f of 1, this is also f of 1. So we have 2 times f of 1 on the right side, and then here we also have 2 times f of 1, and then f of 0 is 0, so here it is also f of 1. So in such a way, we can actually cancel 2 on both sides, so it leads to f of 1 equals 0 or 1. Okay, so here we have 2 subcases. Let's consider case 2a. Okay, to be f of 0 to be 0, and f of 1 is also 0. So here, let's try to pick p of x, comma 1, comma 1, comma 0 to see what we get. Okay, so here we have a f of x, and then plus z is 1, so we have plus f of 1, and then times this is actually f of 1 plus f of 0. Okay, so we can see f of 1 is 0, f of 0 is also 0. So this whole term is a 0. 0 times anything is also 0 on the left side. And on the right side, we have f of x times y is actually x times 1 minus 1 times 0. And then plus f of x times t will be x times 0 plus 1 times 1. Okay, so this is actually f of 1, which is 0. This is actually f of x. Okay, so here it says f of x is equals to 0 for all x are real number. That will be our second solution. So actually the first two solutions are trivial solution. So let's see for the case 2b. We have f of 0 equals 0, and f of 1, here should be f of 0, so f of 1 to be 1. Okay, so here we can try to pick p of x, comma x, comma y, comma y. Okay, so let's see what we'll get. So on the left side, f of z plus f of x plus f of z will be f of x plus f of y, and then f of y plus f of t. Y is x, t is y, so it is also f of x plus f of y whole square on the left side, and then equals f of xy is also x, so it is x squared minus y squared. So we have f of x squared minus y squared, and then plus f of xt, x is x, t is y, and then y is x, z is y, so we have f of 2xy. Okay, so let's call this equation 1, and then next let's try to pick p of x, y, y, x. Okay, so we'll get actually here we try to exchange y and t, and actually for the original function equation, y and t are symmetry. So actually exchanging y and t will give you the same thing on the left side. And then on the right side, xy minus yx is actually f of 0 plus the second one is x squared plus y squared. So this is f of x squared plus y squared. So here we have f of 0 to be 0. So this is actually f of x squared plus y squared. So let's call this equation 2. And then we also try to pick p of 0, 0, x1. Okay, so here x is 0, z is x. So we have f of x, and then f of y plus f of t. Y is 0, t is 1, so which is f of 1. Okay, f of 1. F of 1 is 1, so 1 times f of x is f of x on the left side. And then on the right side, we have f of x times y. 0 times 0 is 0 minus x times 1. So this is actually f of negative x, and then plus x times t. 0 times 1. 0 times 1 plus 0 times x, so which is f of 0, which is 0. So we get f is an even function. F is even. Okay, so next In equation 2, let's try to pick x to be square root of x. Of course, this x should be a positive number, positive real number. And then let's change y to be 0. Okay, so in such a way, on the left side, we have f of square root of x and then quantity square, because f of y is 0. Okay, and then on the right side, we have equals f of x. Okay, so as much as this is a square of a real number, so this is greater than or equal to 0 for all x is greater than 0. Okay, so let's call this equation 3. Okay, now, so next, suppose we have a and b are positive real number, and we have a is greater than b is greater than 0. And then we try to let a plus b over 2, which is actually the average value of a and b, so which should also be a positive number, and we define it to be x squared. So this is greater than 0. And then we also define that this average value minus this smallest number b, it should also be a positive number, and we try to define it to be y squared, which is greater than 0. Okay, so which means that we can have a b equals x squared minus y squared. So here we can try to solve a to b. From this equation, we can have a equals 2x squared minus b. And then plugging in this equation, we have 2 times x squared minus x squared minus y squared. So actually we have x squared plus y squared. Okay, so here we can evaluate f of a to be f of x squared plus y squared by this equation, and then making use of equation 1 and 2. Okay, f of x squared plus y squared, which is this one, will be equals to this one and also equals to this one. So finally, f of x squared plus y squared equals to the right side of equation 1, which is f of x squared minus y squared plus f of 2xy. And actually this one is b, so we have equals f of b plus f of 2xy. And as much as this one f is greater than or equal to 0, so it is greater than or equal to f of b. Okay, so we prove that f of a is greater than or equal to f of b if a is greater than b, which means that f is increasing for positive input. Okay, and then next we try to define a function g from positive real number to real number such, and also we have a g of x equals f of square root of x. And as much as f is a positive number, so g of x is also greater than or equal to 0, or at least a non-negative number. Okay, so here we have a xy to be positive real number, so we have a g of x plus y quantity square, and then according to the definition we have equals f of square root of x plus y and then quantity square. And then here we try to make use of equation 3, which is here, actually this one. So we can actually move this square to cancel this square root inside the f. So which means we have f of x plus y. And actually we can consider x to be square root of x and then quantity square plus square root of y quantity square, as x and y are positive real number. Okay, and then here we can make use of equation 2, which is actually this one. So we have f of something square plus something else square equals to this one and this one, add them together, and then whole square, which means that we have f of square root of x plus f of square root of y whole square. And by the definition of g, we know that it is actually g of x plus g of y whole square. Okay, from here we know that g is always a non-negative number, so which means that we can just take square root on both sides, so that we have a g of x plus y equals g of x plus g of y. So it turns out to be a Cauchy equation, but we need some additional condition so that we know the solution to be a linear function. Otherwise, we can only know the solution to be linear function for rational number. And actually, we can simply prove that g is an increasing function. So suppose we have x to be larger than y. I mean, x is larger than y is larger than 0. Okay, so in such a way, as much as square root is a monotonic increasing function, so which means that square root of x is also greater than square root of y is greater than 0. In such a way, we know that g of x is equal to f of square root of x, which is greater than or equal to f of square root of y, which is equal to g of y. So which means that g is increasing. So we call this star and this is double star. So from star and double star, we know that g of x is actually a linear function. Okay, and we can just plug it back to the definition of a g of x. So we know that f of x is actually g of x squared, which means that it is c times x squared. And we already know f of 1 is 1, and it is also equals to c times 1 squared. So we have a c equals 1, which means that f of x is actually x squared for all x are real number. So finally, we get 3 sets of solution. So f of x equals 0, 1/2 or x squared for x to be real number. Okay, so actually we can simply check whether it's satisfied. So the first one, if f is always 0, so the whole thing is actually 0 equals 0, which is okay. So we can easily check this one. And if f is always 1/2. So this is 1/2 plus 1/2, which is 1. 1/2 plus 1/2 is also 1. So 1 on the left side. And then 1/2 plus 1/2 will be 1. So 1 equals 1. So this is also okay. And then finally, f of x equals x squared. So on the left side is actually x squared plus z squared. And then times y squared plus t squared. So expanded out, we can have x squared plus x squared y squared plus x squared t squared, and then plus y squared z squared, and then plus z squared t squared. And then for this one, okay, xy minus zt squared will be x squared y squared, and then plus c squared t squared, and then with the cross term minus 2xyzt. And then for the square of this one, we have x squared t squared, and then plus y squared z squared, and then plus 2xyzt. Okay, so this one and this one cancel. And then we can simply see that this one is this one, this one is this one, this one is this one, this one is this one. So we also check the third one is also the solution. And this is the end of the video.